In April 2025, the world's most advanced humanoid robots found themselves caught in the crossfire of a geopolitical chess match. As Tesla CEO Elon Musk took the stage during the company's quarterly earnings call, the tension was palpable. Behind his characteristic optimism about the Optimus robot's potential to revolutionize labor markets lay an uncomfortable truth. China's sudden restrictions on rare earth exports had thrown Tesla's ambitious production timeline into disarray. This wasn't just a corporate setback. It was a stark reminder of how the delicate threads binding global supply chains could unravel with a single policy shift. The crisis began quietly on April 4th, when China's Ministry of Commerce announced new licensing requirements for 7 critical rare earth elements. To the average observer, the list, samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium, might have sounded like obscure entries from a chemistry textbook. But for engineers at Tesla's Fremont facility, these medium and heavy rare earths represented the beating heart of their Optimus robots. Buried within each robot's 10,000 components, rare earth magnets enabled the precise, efficient movements that made Optimus more than just a metal shell. Without them, the robot's arms would lose their dexterity, their actuators would grow sluggish, and Musk's vision of a humanoid workforce would remain trapped on drawing boards. China's move came as a calculated response to the Trump administration's latest tariff escalations, but its implications stretched far beyond tit-for-tat trade politics. For decades, the world had grown complacent about China's near monopoly on rare earth processing. By 2025, despite periodic warnings about supply chain vulnerabilities, China still controlled 90% of global refining capacity. The new restrictions exposed this dependency with brutal clarity. Automotive manufacturers typically kept just 2 to 3 months' worth of rare earth inventory, a prudent strategy in normal times, but catastrophic when export licenses suddenly required 60 days to process. Tesla's robotics team found themselves staring at spreadsheets that turned redder by the day, their production lines inching closer to paralysis. Musk's candid admission during the earnings call, "We reworking through that with China," belied the complexity of the challenge. Securing export licenses meant navigating a bureaucratic labyrinth where technical specifications blurred into geopolitical posturing. Chinese authorities demanded assurances that these magnets wouldn't be diverted to military applications, a reasonable request on its face, but one that required Tesla to open its playbook to foreign scrutiny. Engineers in Palo Alto found themselves drafting unprecedented levels of documentation, mapping every gram of rare earth material from Chinese refineries to Californian assembly lines. Meanwhile, Wall Street analysts began recalculating their models, wondering aloud whether Tesla's promise of thousands of Optimus units by year-end had transformed from business plan to wishful thinking. The ripple effects extended far beyond Tesla's headquarters. In Washington, policymakers confronted uncomfortable questions about national security. The same rare earths powering Optimus robots, fingers also guided Tomahawk missiles and enabled the radar systems on F-35 fighters. A Pentagon report revealed that each Virginia-class submarine contained enough rare earth elements to build nearly 1,000 Optimus units, a comparison that highlighted both the scale of military dependencies and the absurdity of humanoid robots being caught in an artillery-grade trade dispute. Congressional hearings suddenly buzzed with talk of accelerating the Mountain Pass mine expansion in California, where MP materials struggled to scale operations that could one day challenge Chinese dominance. Across the Pacific, Chinese robotics firms sensed opportunity. In Shenzhen, UBTech Robotics accelerated production of its own humanoid models, leveraging unfettered access to rare earth supplies. State media coverage subtly contrasted China's smoothly humming factories with Tesla's idled lines, framing the situation as a testament to self-reliance. Market reactions were immediate and stark. While Tesla's stock dipped on the earnings call news, shares in Chinese robotics firms like UBTech and AI Robotics surged double digits. The message to global investors was clear. In the new era of tech competition, control over materials might matter as much as engineering prowess. Yet the story wasn't simply one of East versus West. European manufacturers, though less reliant on Chinese rare earths than their American counterparts, watched the situation with growing unease. Germany's robotics consortium quietly reopened discussions about Greenlandic mining partnerships, while Japanese firms accelerated recycling initiatives for rare earths from discarded electronics. The global race to diversify supply chains, once a theoretical concern for sustainability reports, had become an operational emergency. Back in Austin, where Tesla had recently consolidated its engineering teams, the mood blended frustration with determined innovation. Teams explored stopgap solutions, redesigning actuators to use lighter rare earths not on China's restricted list, testing synthetic alternatives, even considering temporary shifts to less efficient motor designs. Each option carried its own trade-offs: performance compromises, extended testing cycles, potential delays in achieving the lifelike movements that made Optimus stand out. Musk's insistence on maintaining the production timeline added pressure, with some engineers working consecutive overnight shifts to simulate years' worth of wear and tear on prototype components. The human dimension of the crisis gradually came into focus. In Baotou, China's rare earth capital, workers at magnet factories found themselves thrust into geopolitical significance. "We're just making the same components as always," remarked one technician, who requested anonymity. "But now there's extra paperwork and foreign executives visiting every week." Their output, previously destined for electric vehicles and wind turbines, now carried implications for international diplomacy. Chinese trade officials walked a tightrope, balancing the desire to pressure Western governments with the risk of pushing companies like Tesla to accelerate alternative sourcing strategies. For American consumers following the news, the situation crystallized abstract debates about supply chain resilience. The average smartphone user might vaguely know that rare earths powered their device, but seeing humanoid robots, those sleek avatars of technological progress, stymied by backroom trade disputes, made the issue visceral. Social media buzzed with memes juxtaposing Optimus's futuristic design with 19th-century mining carts, a stark visual metaphor for how raw material dependencies could tether even the most advanced innovations. As April drew to a close, the path forward remained murky. Tesla's government relations team shuttled between Washington and Beijing, seeking political solutions to what was fundamentally an engineering problem. In confidential briefings, State Department officials debated whether to link rare earth access to other trade concessions, a high-stakes gambit given China's dominance. Meanwhile, materials scientists from MIT to Stanford raced to develop magnet technologies that could bypass rare earths entirely, though practical applications remained years away. The Optimus predicament underscored a paradoxical reality of 21st-century technological ambition. The more sophisticated our creations become, the more deeply they're entangled with ancient geological processes and modern political realities. Those humanoid robots, designed to embody the pinnacle of artificial intelligence and mechanical elegance, now served as unwitting ambassadors for a critical truth. In an era where a single policy shift in Beijing could stall assembly lines in California, true innovation requires not just breakthroughs in labs and workshops, but a reimagining of how the world sources, shares, and secures the building blocks of progress. As summer approached, all eyes remained on China's export license approvals. Would Tesla's applications clear before inventories ran dry? Could alternate suppliers in Vietnam or Malaysia ramp up production quickly enough? The answers would shape more than just robot production timelines. They would test the resilience of globalized manufacturing itself. For Elon Musk and his team, the crisis became a crash course in geopolitical strategy, a reminder that even visionaries who aim for Mars must navigate the earthly complexities of trade policies and mineral supply chains. And for the rest of the world, it served as a wake-up call. In the race to build tomorrow's technologies, control over yesterday's elements might determine who leads the future.